Hello everybody, welcome to another Advent of Code session. This time it's gonna be day 10 after a short delay because I was traveling and stuff like that, so I didn't have time to record more videos, but I'm back now, so let's do day 10 now. So I have already read the problem descriptions, I have some general idea how the solution will look like, but I haven't tried it yet, so it's gonna be interesting. We will see if my assumptions will hold. So just to describe the problem, we are solving a pipe maze where we have a map of the maze that's described by these various characters, where there is a vertical pipe, there is a horizontal pipe, there is 90-degree bends in various directions, and there is a ground where there is no pipe, and finally there is a starting position, which is the place where we will start discovering the maze. And it's basically a position of an animal that we are trying to find in the pipe. And the fact is that the whole pipe that we get in the input is a large continuous loop that starts in one position and ends in another position, whereas one of those points is the starting position, which is a general pipe. We don't know how it looks, but it's one of those 6 pipes that are described here. And our goal is to discover what the maze looks like and then find the position in the loop that's the farthest from the animal. To make this more complicated, there is a lot of additional pipes which are either connected but don't end anywhere, or are not even connected to the maze, to the main loop, and are there just to confuse us. So we need to figure out which part of the pipes make up the main loop itself. So that's gonna be the tricky part of this problem. And let's see if I forgot something here. Yeah. So there's a lot of examples here. So there's a lot of ways, a lot of potential to test things out. But the goal essentially is to find the main loop and then figure out what's the farthest position on the loop. That distance from the starting point is then counted as the result of the problem. So let's get started on this. So I will first take some simple example, which is this one, and then start solving this. So what I will need is to read the input first. So input, yes, read all lines of the input, and now we'll have I will probably put it into a 2-dimensional array. So map is gonna be of input. So I want to have it x and y, so I will do input 0 length and input length. So whereas this one is going to be width, and this one's going to be height. And now I'll read the input into that map. So for x and y, I'll just put it, yeah, exactly. I will write, just read the input into the map, character by character, nothing too special there. So now that we have this, to find the shortest, like what we need is to find where we are starting, the starting point. So what I will do during the reading, I will store the position of the starting point. And I will check, yeah, we have tools here. So starting position. That's gonna be new point. And now we'll read that position. So if map x y equals s, so we are on the starting position, then we store that, or not really, let's put it like this. So if the starting position is here, then we store that position, and we now know where we are starting. And we will, what we'll do is we'll do a depth first search. So I will start in the starting point and then kind of go through the maze. We will find the direction that we can go through, and then I will start going into the depth of the graph and start going through it until I go back to the starting point some way. And that when we reach the starting point from another direction, it means that we have found the main loop. So when we do that, we can count the number of steps we have taken to figure out the farthest location, which is going to be like the half of that length that we have traveled through the maze. So I will create a method, depth first search, first DFS, which will give a start at the position, and we'll count the steps. So it's gonna be steps. Copilot is trying to help here a lot, but I want to solve this myself. So let's do it like this. And now what we will also need is to keep track of the places that we have visited. So I will do exactly this. I will have a visited array. So now when we're at a specific position, we need to first see if we are on a visited position, if that position is the starting point. If it is, then we found the solution and we can essentially write it out. So I will do if map position xy equals s and visited position x, position y. So if we have already visited s, so this is not the beginning of the execution, and we found exit already, so we can do steps. So we can do console write line steps divided by 2, which should give us the half of the loop. And the loop is, if the loop is has length of let's see, if 1 2 3 4 5 6 7 8, it's gonna be half of it. Yeah, so yeah, it should be the half. Yeah. Okay, so we have this. Then we have, so this is a ending condition, kind of. Now, if we're not in the starting point, we can figure out where we can go by going through all the directions that are available. So for each direction directions are in directions. We don't support diagonals, so without diagonals. And now position is gonna be position plus direction. So first we need to check if we are not going outside of the map, and if we are, then we just skip it. We just continue without going forward. Then if the map next position y equals s, so if we okay, so what we need to do here first, that's important, is to mark this position as visited. So if the next position is already visited, that means that we are closing some kind of loop. And the question is, can it be something else than starting point? Yes, because we can go back to the previous point that we already visited. So if it's visited and map next position x y not equals, okay, right. We need to prevent us from going back to start after the first step. So we need to check if it's not. If it's visited, or no, if it's visited already, and it's not starting point, then we continue. Okay. Let's see. If it's already visited, so we need to prevent going back to start after the first step. That's the first thing. Our next steps plus plus. So we are making a new step here. And now from here. So essentially, I want to check all available next steps, next positions. Or maybe what I can do to prevent going back is to also mark down the point previous position, current position, and steps. So this will prevent me from going back to the previous point. Current position is the position that I'm standing on. And next position is going to be the next one. So if next position is outside the map, we continue. If next position equals previous position, then we continue, because we don't want to go back right where we started immediately. And now next we need to check all the if the position, the next one, is reasonable, if it makes sense that we can go there. So if the next position is a dot, we cannot go there. If then based on the direction, we need to figure out if the two pipes, the one on where we are standing right now and the one that follows it, are connectable. So so based on the direction, so let's see, if direction equals directions. Okay, so we can do, if you're going to the right, there are only several possibilities. So if you're going to the right, then it can be either 2 horizontal pipes, or rather, the next one must be if you're going to the right, then it must be either 7 okay, maybe you do next pipe equals next position, current pipe equals this. So basically we're checking if the direction is valid. So if we're going to the right, then the next pipe must be, if direction is right, and if so it can be 7, or it can be J, or it can be horizontal pipe like this. So let's start this valid false. So it can be all of these, and it can also be S, like next pipe equals S. So in these cases, the next pipe is valid. So next pipe is valid. So it must be one of these options, and also our current pipe needs to be something that we can go to the right from. So our pipe must be either L, or horizontal pipe, or S, or there's one more, must be F, right? So this is the logic that we need, and we will need it for all the 4 directions. So else if direction equals point of, and this is going not to the right, but this is going to the right. So this is going to the left. So if we're going to the left, then it must be F, L, or this, and it's going to be J, or 7, or S, or horizontal pipe. Now, the same things for direction of up, which is going to be, or down, this is down. So this is going to be, it can be either, next can be only L, or J, or vertical pipe, or S, and we need to be going from F, or vertical pipe, or from 7, right? 7, And for direction of up, we need to be going from to S or to vertical pipe or to we need to go to, all right, we need to go to 7 or to F. And the source basically is the flip side of this logic there. So we need to be going from L or from J or from vertical pipe or from S. Yeah. Okay, so this will check if the direction is valid, and if it is valid, then we can go one step further. So we go to current to next position, from current position with a number of steps, and that should be it. Yes, that makes sense, I guess. Now we just need to figure out if this is going to stop at the right point. So if the next position is not S, and it's already visited, then we skip it as well. So this should terminate now, and technically we should be able to solve the problem, but we will see. So DFS, oh, okay, DFS, I'm complaining. Starting position 0 steps, and I will maybe do this as the previous point. I will do -1, so that just to make sure that we don't confuse it. The previous position is used only to check the previous one, but otherwise it's fine. So this could be functional. We'll see. Maybe I missed some detail, but overall it should make sense. So it says 4, which in this case is correct. So let's try a more complex version. It's 8, so that's fine. Okay. I'm not sure if I dare to try this on the big example already, but so far it seems to work. So let's see. Let's try the whole thing. Okay, Stack Overflow. That's not good. Definitely something is wrong here. So let's see. So there's some termination condition that I didn't consider here. But which one is it? Yeah, we never reached this place. So how can we reach Stack Overflow if we are marking the visited ones properly? Like, the size of the input is not that huge, so it shouldn't be a problem. So if we go outside the map, we continue. If we try to go to the same position again, we continue. If we reach dot, we continue. If the next position is not S, but is already visited, we continue as well. And Okay, let's try to run this. Okay. So if it's valid, we get, let's see, visit it. So this seems to be fine. I am not sure what could be the problem. Maybe it's just that we are using recursion, which is not something that we just go over the stack. So maybe we could turn this into a while loop. So stack and do while stack. It should be a point previous, point current, and steps. So while stack count greater than 0, and this should be enough. So essentially we turned the method into a stack-based recursion. So stack pop. Now we have the values that we need, and instead of DFS, we will be adding this to the stack. So stack push current position, next position, steps. And initially we need to put in to the stack starting position, and 0. That makes sense. So let's see. 6,838. And that's correct. All right, so the problem was there that we were just doing too much of a recursion, and that overflowed the stack. So instead of that, I just created normal stack and put those positions and values there, and apparently that's all it was needed. So yeah, that's good. We have solved the first part of the problem. So now let's go on to the next one. So let me copy the program input, the program code for now. Let's put this here. So the second problem of this problem is very different. So maybe not even be using that much of the code that I've written so far. The goal of the second part of the problem is to calculate the area which is close by the main loop. So essentially, when we have the loop figured out, we need to find out which points, which of the dots in the map are within that loop and which are outside of that loop. So basically those zeros here are not inside of the loop, and those i's are inside, because the loop is looking like this, like it's going here and then inside. So only these two dots and these two dots are part of the loop itself. And then it gets quite tricky, because we need to figure out which part, like in a very complex map, we need to figure out where those dots are. So that's going to be quite interesting to see, because when the map is very convoluted with a lot of things that don't belong there, essentially because they are not part of that loop, it will make it much harder to discern what should be inside and what should be outside, and what is relevant to us. Like the way to solve this, to figure out if a point is inside of a polygon, is by doing raycasting, which is that you go in one single direction. So for example, to the left of the point, and count the number of times you cross a line. So if we're here on this dot, we can go here, and if we cross the line only once, which means that we are inside of the loop. If we are here and try to cast the line, it's gonna be that we cross the line once and twice, which is even, which means we're outside of the loop. So whenever it's odd number of crossings, then it's inside, and whenever it's even number of crossings, it's outside. So what we need is to clean up the map so that we have only the things that make up the main loop there. And then we need to figure out how many, for each of the dots in the loop, in the map, how many times does it cross the loop. So that's gonna be very interesting to see. The question is, do we count only the dots, or even like pipes that do not end up anywhere? So I think it's just the dots, but just want to verify. Yeah. Squeezing between pipes is also allowed. Yeah, of course. Yeah, makes sense. Okay, so even junk pipes can be counted as being closed. So yeah, so what we will need is now that we know how long that pipe is, we need to clean up the map so that it contains just the main loop. So how do we do that? So maybe instead of visited, I will do distance. And initially, all of those distances will be distance yeah, let's do max value. It can be max value, I guess. Or maybe not. Yeah, let's do -1. So we cannot get there because it's -1. If distance null equals -1, then distance steps. Then we have here distance null equals -1. And finally, yeah, that's fine. Okay, so when we find the solution here, so when we find the final position, loop length, and when we find the loop length, we will store that loop length here. So it's gonna be steps. So that's the number of steps we had to take to reach S again. And now to reconstruct the path, we can go from starting point and go backwards through the maze. So what we can do, is main loop, and we can mark down what points on the map are part of the main loop. So for steps, or rather, zero. Actually, the starting point should be on 0 steps, which should be fine. Okay, so while steps loop length. Do we need the loop length anymore? I don't think so. I think we just need to have this. So main loop, starting position X and Y. Yeah, so starting point is always part of the loop, and now we will go with this. So our current position is starting position, and we will do for each step, we'll go through all the directions for each direction in directions without diagonals. We will take next position equals current position for direction. We will check if we're inside of the map, and if we're not, we skip. And if map, so this is going to be, yeah, okay. So current position, loop position. So yeah, like this. So if the next position on the map has the appropriate amount of steps. So if steps visited, how is it called? Distance, yeah, distance of the next position X, next position Y equals loop length, and it's actually should be loop length minus here, because we need to start decreasing continuously the loop length. If it's loop length, then main loop next position is true, and then we skip to the next position, and we can break here. So we just need to find the one point where that we used to get there. So that should be fine. I think this way we should be able to find the main loop, and we can actually test this. So console for X, Y, or actually Y and X. We will write do console write if it's part of the main loop. I will do X, and otherwise I will do dot. So it's just to draw the line where it goes, so we can see how the map looks, and if it makes sense. So console write line. So now it should draw out the map, and I will try it on a more simple input. So I will start with this one, if that makes sense. All right, so let's try running this one. Okay, so that's not what I wanted, definitely. Let's let's see, I made some plus minus error, I think. So here we have what? So the main loop, false, now in directions, and so the distance. So loop length is 45. Okay, that's interesting. That's very interesting. There is no 45, there's 1 here for some interesting reason. So why is it there? Why is there 1? That's pretty odd. Right, 3 is 1. Oh, maybe it can happen that we overwrite the steps count on a point. Can it happen? Yeah, I think it can happen here. So I think if we do a break here, it should be better. Yeah, okay, that makes sense. Okay, so I forgot to do a break there, and then it meant it after finding the solution, it could also still continue searching for the solution and overwrote our existing distance, and that could be a big problem. So that is now fixed. Let's try this. So it has some drawing header, so it could be correct, right? Yeah. So now what we need is to calculate the number of points that are enclosed. So for each, so we'll go for, again, for y to x. I'll just comment this out. So basically we will go for the whole map, and for each of the points which are not part of the main loop, if main loop xy, if we're not in the main loop, then we find if this point is inside or not inside. So raycast, I will do raycast xy. So if, or rather, if in main loop xy, so this will, I will have to counter, so in counter 0. So now if it's going to be part of the main loop, I will just increment the counter. So very simple. And now this final thing, which is the in main loop method, which will be checking if the point is part of the main loop. So point, so x, x, y, and now we will go like this. So we'll go to the left of the point, and we will count the number of times we cross the main loop. So for So for x greater than 0, and we go x minus minus greater or equal to 0. So now we check if x minus minus. So we go to the first one before our position, and crossings is gonna be 0 initially. So we will check if we cross the boundary, and we need to check this by checking how many times we cross J, L, or pipe, or S, I think, because S can be a tricky one. All right, we need to. It would be nice to fix up S to be the actual character, not just S. Because otherwise it could confuse us. If it was a horizontal pipe, then it wouldn't count as a crossing. So yeah, we need to fix this. So here we will fix the S. Just S. So let's see if we. So we need to see which character it is. So if +1 and starting position Y. So if it's, so there are several options. So if S is a vertical line, it means that there is main loop above it and below it. So this is okay. So not like this. All right. So if there is so this is for the horizontal one. So if there is a main loop, oh, not like this, because we need to it's a little bit more tricky than I wanted. Okay, so we're at the starting position and go. We know the number of steps, so yeah, okay. Essentially, just we just need to figure out if S is a horizontal pipe, because the other ones we are interested in. So is horizontal pipe equals map main loop starting position. Okay, so or rather like this. If distance of starting position X +1 starting position Y equals 1, and distance starting position -1, yep, we need to keep the loop length intact. So yeah, so original loop length. So if, and this is equal to loop length -1. So if it's this way, or if distance So these are the two options that will tell us if the S is horizontal pipe. Okay, so now if map, so all right, main loop xy, what is this? Oh, if it's a main loop, and if we are crossing the main loop, and map xy not equal to horizontal pipe, and if S is also horizontal pipe, then y equal to S. Oh, if S is horizontal pipe, we can just rewrite it, so it makes sense. So starting position X and Y, we can just simplify this and just replace it by horizontal pipe. Easy. So that makes it quite simpler. So if it's not a horizontal pipe, then we count the crossing, and if crossings modulo 2 equals count 0, then it means that it's so if it's not 0, then it's part of the main loop. So that should be it, I guess. So let's test it on the simple input first. All right, I didn't write the result. That's quite important. So now console write line counter. Let's see, 6. That's quite a lot, I think. Should be less. Should be just 4 of those there. So what is the main problem here? Okay, let's write this out. So console write. So if it's main loop, then I will do X. So else here. So if it's in the main, if it's the main loop, then I will write an X there. If it's not the main loop, then I will write either I or O. So now it should show us how the map looks. Console write line. Let's see. There we have some trouble. So it says that this one is, that definitely doesn't make sense. So it says that this point is inside. Why? 3. Oh, because, yeah, of course, because this is 1, 2, 3. There are essentially 3 points where it crosses, even though, but it's not inside. And that's because when we're here, we are inside until we leave. Okay. That's quite interesting. So we can care about only I and L, maybe? So I L. So this could be it, maybe. All right, so still not it. Now it's actually even worse. So, oh, right, it's not I, but it's pipe, particle pipe. So, we have moved somewhere, but it's still not it. So, IL. Yeah, because we need to have those chased there. Yeah, so how do we figure this out? So why does this matter? In, out, in. So what is how do we discern this? This makes it a little bit more complicated. Because we need to ignore horizontal lines, but so run 2, 1, 2. There is 1, 1, 2, 1, 3. So there are 3 crossings, but we're not inside the loop. That's because how does this work? I must say I'm now a little bit confused because I thought the algorithm works like this, but 1, 2. From that point we cross it once. So yes, so from here we cross the boundary once. From here we cross it twice. But from here we cross the boundary once, twice, 3 times. So why is that? Why does it not work here? So if we cared only about vertical pipes, that doesn't work. That cannot be enough. So because that will break for this one. That will break for this one. There's just one here. And we need to care about this kind of thing. So casting, how does it work in this case? I'm a little bit confused now. So in this case, it's 1, 2, 3. It makes sense for those which are just against the vertical pipes, but then I get confused about how to solve for the horizontal ones. So this should count as just one crossing because it's kind of the horizontal line that we are crossing. So let's do it like this. In horizontal false. So if you're going to the left, and encounter a vertical line, then we crossed it. Else, if the line false. If we encounter a well, next to us, if we are a dot, then next to us cannot be a horizontal line on a main loop. That makes sense. It can be only a 7 or a J. So if it's a 7, map equals J. So if we are next to these two, on our left, it can be only 7 or J. We need to start a horizontal line. So we shouldn't count this as a crossing. Should count only an L as a crossing. So, oh wait, why does it not work in this case? Let's think about this one more time. So, if it's a vertical pipe or an L, why doesn't this work exactly? Because of this one. Because for that one, we are it would be like one crossing, even though it's essentially a horizontal line. Okay, so it means that a horizontal line shouldn't count as a crossing. But then, okay, so but then it doesn't work in this case. Why? Because what? Because of this one then. All right, so after a few more tries, I figured out what is the trouble there. Actually, we need to count the number of like 90-degree changes that we are encountering, but not the ones where something like this, like a chimney, it does not count that much because you go down and back up, but you need to count those where you go from up and then down. So in that case you do cross the boundary, but in this case you go right in parallel with the boundary, so that doesn't shouldn't count properly. So we need to count the number of L's and J's, for example, and the vertical pipes always, so that you know that in this case you count 2, which is even, but in this case you can't count just one of them, but not the other, which is odd, because that's an actual crossing. So this way, if I count J's and L's, the result is correctly 4. So that should make sense. And now let's see if it works for a bigger example as well. We can try the big one, but I guess that could still be problematic. 451. And that is correct. Okay, so that was a lucky one. Actually, the problem could have been when, in case if the starting position was one of those two characters, so either J or L, because then that would kind of break the logic. So instead of that, then I would have to really make sure that the S character has the proper position. So S character is replaced by the proper replacement. So it could be a horizontal, vertical pipe, S7, J, L, or F, and then it would work properly. But in this case, I was lucky because S, the starting position was neither of J or L or vertical pipe for the matter. So it means that it worked out correctly. So okay, so this one was a lucky one in the end. But yeah, the logic to replace the S with the proper pipe would be to check the distances around it and to check if what does that pipe resemble. So if for example, if the distance of one would be to right and distance of loop length would be on top, then it would be an L, and so on. So you would just go through all those options and make sure that the pipe, the character is replaced by the proper pipe in this case. But yeah, I think this is a solution, even though it took a little bit longer than I expected, but now we have it. So I hope this was useful, at least as a kind of template on how this can be solved. And I will be back for next days with more videos. Plus I will do another video about ChatGPT solving this problem. We will see how tricky it will be for it to resolve this. And I guess it might be quite problematic. We'll see. So if you want to get notified, subscribe to my channel and get notified about future videos. And I will see you in the next one. Bye bye.